Hi, today we're going to be talking about comparing fractions. And we're going to start with a math message. There's a book called Eating Fractions, and these problems kind of go with that, but we're not going to read the book here on the video. Our question goes like this. Quinn, Nancy, Diego, Paula, and Kiana were given 4 chocolate bars to share. All 4 bars were the same size. Quinn and Nancy shared a chocolate bar. Quinn ate 1/4 of the bar, and Nancy ate 2/4. Who ate more? So down at the bottom of the screen, I have a couple of pictures, one in blue, one in red. So we're going to pretend that the one in blue is the candy bar that Quinn and Nancy have shared. And as you can see, I have it divided into 4 parts because our denominator is 4. And basically what they're saying is Quinn is going to eat 1 part of that bar, which would be this, and Nancy is going to eat 2/4, which would be this. So we've got Nancy here with those, and we've got Quinn here with this one. So who ate more? Of course, you can see from the picture, and you may have known before the picture, that Nancy ate more. How much of the bar was left? We've got 1 piece left out of 4, so our fraction would be 1/4 left, and of course Nancy was the one that ate the most. So if we look at problem 2, we have Diego, Paula, and Kiana each ate part of the other chocolate bars. Diego ate 2/3 of a bar, Paula ate 2/5 of a bar, and Kiana ate 5/6 of a bar. Who ate more, Diego or Paula, and how do you know? So if you recall, we started with 4 chocolate bars, right? So we're going to, we know that Quinn and Nancy already split 1 of them. There's 3 left. So if we think about Diego, we would have 1 bar that we divided into thirds. Paula's bar we would divide into fifths, and Kiana's bar we would divide into sixths. So when you think about those fractions, the pieces get smaller when the denominator gets bigger. Think about that for a minute. The pieces get smaller when the denominator gets larger, because if we have the same size of a bar and we're dividing it into 3 pieces versus 6 pieces, that means each piece is a lot smaller. So who ate more? Can you figure out the answer to that one? If you said Diego, that's probably who I would go with, but we would have to do a picture to go with that. So in your notes, you could draw a picture, but you've got to make sure that you make each of the bars exactly the same size and then divide your pieces. You can show me your answer when you come to class. Okay, so sometimes we're going to have fractions when we compare them that have like numerators, meaning that all of the numerators are the same, like the 4 that I have written here, 1/2, 1/3, 1/4, 1/5. So you can see that all of the numerators are the same, but my denominators are different. As the denominator gets larger, the fraction gets smaller. I know that might not make sense, but think about it. As the denominator gets larger, the fraction gets smaller. As the denominator gets larger, the pieces get smaller because the whole is being divided into more pieces. So if you take a look off to the right, I have a drawing, and my lines are not exactly where they need to be because I didn't have a ruler to measure and it's hard to do on the screen. But this shape right here is supposed to represent 1/2, and the one below that would be 1/3, and then we have the one below that, which is 1/4, and the one below that, which is 1/5. And my lines kind of got moved around there. If I can get that. No, I can't move that, sorry. I thought I could move my bottom there to the top square, but it's not going to work. But as you can see, there are more pieces when we change the denominator, and our pieces are going to get smaller. Now, sometimes we're going to have denominators that are the same and our numerators are different, as in this case. As you can see, 10 is my denominator for all of those fractions, and my numerator is different. So the larger the numerator, the bigger the fraction. The larger the numerator, the bigger the fraction. All the pieces are the same size, so more pieces make a bigger fraction. So usually when we have fractions that we're comparing and they have all the same denominator, the only thing that we need to look at, if that's the case, is the numerator, and we can basically put those in number order if we were going to list them from smallest to largest, like I did here, because my 0 is the smallest numerator, so that would be the smallest fraction, and my 10 is the largest numerator, so that would be my largest fraction. So a lot of times when we compare fractions, we're going to have a mix. We might have some numerators that are the same, some denominators that are the same, but they're not always going to be real easy for us. So sometimes we need to use some tools. And one of the tools that we can use are these fraction bars, and I have some magnets in class that I can let you look at. But looking at this, it's really easy to look at 1/2, for example. And if I take this ruler and line it up with the edge of the 1/2 and go all the way down, I can see that 2/4 would be equivalent to 1/2. 3/6, my ruler's not quite lined up, but 3/6, 4/8, 5/10, and 6/12 are all equivalent to 1/2. So that's the neat thing about these fraction bars, is I can take a ruler and line up all my pieces and move this around, and I can see equivalent fractions, which is a little bit easier than using our fraction cards and going through a stack. We can also use pictures like you have with your fraction cards, and sometimes it's a little bit easier to see with pictures. I myself like the fraction bars, but it's your choice. But if we had to order these fractions, the 1/2, the 2/10, the 2/6, the 2/3, and the 3/4, we would need to put them in order from smallest to largest. If you think about what I had told you earlier with your denominators and your numerators and how we can decide if one is greater or not, the fraction bars, in my opinion, are a little bit easier to use. So if we look at 1/2, find it on the fraction bar, and we look at, so we've got 1/2 here, 2/10 would be that many, 2/6 would be here, 2/3 would be here, and 3/4 would be here. Now looking at that, it's really easy to put those fractions in order, because from smallest to largest, my 1/10 is the smallest, so I'd put 1/10 And then my next smallest would be my 2/6. My next smallest would be my 2/3. And then my 3/4. I think I missed one there. Which one did I miss? Got 1/2. Oh, 1/2. We need to stick. Where do we need to stick that one? That one needs to go before 2/3. So we've got to stick that one in there. And now we have them in order from smallest to largest. So you can see, looking at the fraction bars, it's a little bit easier than using your cards. Not that you can't use your cards, it's just another way to look at the fractions. So to summarize what we've done today, we compared fractions with fraction cards, pictures on the fraction cards, fraction tiles. We ordered fractions using fraction tiles, pictures, and fraction tiles. I got fraction tiles on there twice. Didn't mean to do that. So you kind of have to decide. You're not always going to have the fraction bars with you. You have your fraction cards. So that might be one thing that you can use all the time. So hopefully that makes sense. Write down any questions that you have, and I will see you in class. Thank you for watching.